Hello everybody, again I'm here with my new problem of electrostatics. Again we use Coulomb's law to solve this problem. See this, as we have discussed that to solve any problem we have to follow three steps. First step is to analyze the question, what the question is telling us and what we have given in the question and what we have to find out in the question. Second, we'll have to do qualitative analysis, how we go through the question by applying which concepts, mechanical, electromagnetism, quantum, which concept is useful to go through the question. And the third and the final form is the quantitative analysis. We give reality to our qualitative analysis to get the numerical answer, the perfect answer. So we are going to do this. First step, to analyze the problem. See, there are 3-point charges located at the vertices of an equilateral triangle, A, B, and C. 3Q positive kept at A, 2Q positive kept at B, Q positive kept at C. And given here, AB is equals to BC is equals to CA is equals to R. So, entire question is clear. Now, what I will have to find in the question, that's here. The ratio of max force to minimum force in this setup. We have to find this. That's the question. We have everything. We have to find in the question that where force, the electrostatic force is maximum, and which charge you're experiencing the minimum force, and I'll have to find that ratio.
Write that maximum.
I'll have to find that ratio. So, my job is to start with the question. Now we'll do qualitative analysis, the how we solve the question. That's the important thing. For qualitative analysis, first we have to notice, as we have discussed, the force, electrostatic force or Coulomb force, is a vector quantity. So addition and subtraction of these vector quantities are based on vector addition or vector subtraction. That is a resultant of vectors. So see here, each and every charge either on A, B or C can feel force by two other charges. So the total force on each and every charge is due to the presence of two another charges. Suppose I want to calculate force here A. So at A, B is also applying force and C is also applying force. Similarly at C, B is also applying force, A is also applying force. At B, A is also applying force and C is also applying force. So I'll have to find force at any charge and check it. Will it be maximum? Will it be minimum? And I'll have to take the ratio of max charge experienced by any, max force experienced by any charge by minimum force experienced by positive. Yes, similarly, we find force max to any charge and force minimum to any charge and take the ratio. That's the way to solve this question. Now, our third step, quantitative analysis. We have to identify the forces at A. Force at A by B and C. See here, force at A by charge B. Normally that is FAB, 2Q, 3Q, this distance is R. So we have force at A by charge B is equals to 6Q squared by 4 pi epsilon naught R squared. And that force is in this direction, that is FAB. Force at A by charge at C, that is just Q only, that is FAC. That value is equals to Q into 3Q by 4 pi epsilon naught R squared. That is 3Q squared by 4 pi epsilon naught R squared. Now, the direction of FAC is in this direction. As we know, these two forces are repulsive because these two charges are positive. So they are in the line out of the charge at point A. So this is the direction of FAC, this is the direction of FAB. Notice here, we must have to be careful while determining the direction of the forces. Now see, the total force at A will be the vector addition of these two forces, that is this and this. For the vector addition of these two forces, I need this angle. And as I know that this is an equilateral triangle, so this angle, this angle, this angle, they are 60 degrees each. So this angle is also 60 degrees each. Sorry, let me to write it in a phrase way. This is also 60 degrees. Now you have two magnitudes having angle between them, then we can add them exactly. And after adding, we use the vector method. Similarly, I'll have to find force at B by A and C, and angle here is again 60 degrees. And similarly, I'll have to find at C. And among these three forces, I'll have to find the ratio of max to minimum. That's my answer. Let's do some calculation. Total force at A will be this. That will be this FAB plus FAC. That will be something this is squared, this is squared, this is squared. Let's see. Pause it once because it's consuming our time. Is clear? See, we get the total force. Let's see. Total force on A will be FAB plus FAC. Vector addition of these two forces having angle between them is 60 degrees. We get this value by the resultant of forces, resultant of vector by parallelogram law. We can find the 63 under root q squared by 4 pi epsilon naught. Similarly, I'll have to do the same analysis for B also and for C also. Let's see on B. The force by A on B is along this FBA. Force by C along B is in this direction, that is FBC. This angle is again 60 degrees. So by adding these two terms, we can find the total force on B. My space is short, so I need to erase some parts. I'll have to do here the same calculation. See this. Force on B. Similarly, we'll have to go through the same procedure what we have done for the force at A. We get the force of B. Total force at B is equals to FBA vector addition FBC, and that is equal to root under 46 q squared by 4 pi epsilon naught r squared. And I'll have to go the same process for C also to calculate the total force at C. Let's analyze the directional forces first. At C, A also exerts force, that will be repulsive force, so it will go in this direction. So this is the direction of FCA. At C, force applied by charge at B to C is also repulsive and it will go in this direction. So this. And as we know, this angle is 60, so this angle will be also 60. Again, we add the forces here by the same analogy. What we have done at A, at B, I'll have to do at C. So by the calculation, parallelogram law, we can identify this
Stop.
to be. See, the total force, is it visible?
Yes.
The total force
Everything.
on C is equals to FCA plus FCB. That value is equals to under root 19
Yes, 19.
q squared by 4 pi epsilon naught r squared. Now you have all the forces calculated here. So we can identify which will be the max force. The max force is on A by these two charges. and the minimum force is at C by these two charges. And I'll have to find that ratio. So my answer will be something like this. Therefore, F max by F minimum, that will be this. Under root 63 by under root 19. So 63 by 19. We can simplify it in decimal points also, but I don't need to simplify it. This is our answer for the question, max force to minimum force. So this problem has been completed. Thanks for watching. So within this question, I got the final answer. That is under root 63 by 19. What we have noticed in the question, that the max charge is here, so it experiences max force. The minimum charge is here, so it experiences minimum force, and the intermediate charge is here, and it experiences intermediate force. So now in another problem, we can identify exactly that this charge, if the magnitude of this charge will be minimum, it experiences max force. And the charge which has minimum magnitude can experience minimum force. We'll take that ratio, and our answer will be this. So anybody can feel any error in this question, then suggest me, comment me, recommend me my errors, my mistakes within the question, or if you have any doubts within this, then you can ask me also on Instagram, on Facebook, on WhatsApp. You can ask me any doubts based on electrostatics, mechanics, or quantum physics. Thanks for watching, and I will be with a new video in few days.